It all begins with sand, not the golden beach kind, but a specific kind of silica sand, ultra-pure quartz, that gets refined into the glass that will eventually become the protective screen for the next-gen iPhone. Think about that for a second. The sleek slab in your hand once started life in a mine. That refinement process, those chemical reactions, those are the first steps in transforming raw earth into premium tech. From there, we move into the global supply chain, the nodes of sourcing, logistics, and manufacturing that underpin every model in the lineup. Next, the chip, the computer heart of the device, fabricated in advanced semiconductor clean rooms, often in Taiwan or Korea. The die is etched in nanometers, layered with transistors that number in the tens of billions. Once that wafer is sliced, packaged, tested, and shipped, it arrives at an assembly plant where thousands of precision machine tools and robotic arms await. It's here that the board is populated. RAM, flash storage, cameras, sensors, wireless modules, all placed with near-micron precision. The factory floor hums with conveyor belts, collaborative robots using vision systems, human workers performing joinery on flex cables and modules. It's a dance of man and machine, orchestrated to achieve both speed and zero defects. On the exterior, the chassis is made of aerospace-grade metal or ceramic glass composite, depending on the model. Milled, cleaned, anodized, coated, curved, each step adds to the premium feel. Meanwhile, the glass screen gets chemically strengthened through ion exchange processes. The surface atoms are swapped so that the glass becomes tougher, more scratch-resistant. Google this process and you'll find how even the early iPhones leverage this technology to stand apart. Night and day differences. Then there's the back glass, or finish, layers of paint, undercoating, laser etching logos, all handled in exquisitely clean, dust-controlled environments. A speck of dust can mean a reject. Waterproofing, dust-proofing, gaskets, seals, adhesives applied. Each port and each seam receives a pressure test. The device must survive spray, immersion, and still meet aesthetic standards. Internally, the battery is bonded and tested. The camera modules are aligned and calibrated. The lenses are inspected under multiple angles. The speakers tuned individually for frequency response. Wireless antennas positioned to minimize interference. This isn't mass production in the old sense. It's miniature precision manufacturing, optimized at scale. Then begin the lines of assembly. The main board is mated to the screen module. The chassis closes. Quality assurance stations check drop resistance, thermal performance, electromagnetic emissions. Software loads firmware. Sensors are calibrated. Cameras capture test images. A battery cycle runs. Each phone passes through dozens of gates before being boxed. You'll see workers affixing serial numbers, printing barcodes, and attaching packaging which itself has been designed to balance protection, sustainability, and branded experience. What's often overlooked is how much logistics matters in this system. Components must arrive just in time. Storage of parts is minimized to reduce obsolescence risk. The factory partners with air freight, shipping lines, customs brokers, and local governments. With recent shifts in global manufacturing, we're seeing factories not just in one country, but multiple assembly hubs moving from one region to another to avoid tariffs, supply bottlenecks, and geopolitical risk. Sustainability is also now part of the story. Recycling of rare earth magnets, cobalt from batteries, recovery of precious metals from failed units, all part of the life cycle. The factories include solvent-free paint booths, water recovery systems, solar arrays. When you hold a device, it's not just tech, it's the output of a global manufacturing ecosystem trying to balance innovation with responsibility. From the moment raw materials are mined to the moment the device is shipped out of the factory and lands in your hands, thousands of decisions have been made about design, materials, logistics, tooling, testing, assembly, packaging, shipping. Each one adds cost, risk, complexity. That's why the final product has its premium price, but also why so many users feel it's worth it. You're not just buying a phone, you're buying the culmination of global engineering, manufacturing, and supply chain mastery. Now think about you unboxing it. Every piece of packaging, the highlight color, the weight of the device, the subtle click when you insert a SIM, the first boot logo, those are user experience choices layered on top of technical choices. The factory delivered that experience, but the design studio envisioned it. From unseen tools inside the machine to the feel of that first swipe, the factory is the deliverer of promise. When you power it on, the operating system checks sensors, the chips coordinate camera functions, screens. The network module looks for signal, the display adapts to ambient light. It's seamless because the manufacturing process paved the way for seamless. Precision placement of antennas minimizes dead zones. High tolerance ensures alignment. Thermal management within the enclosure ensures performance under load without overheating. Without hundreds of microengineering decisions aligning, your experience would degrade. Beyond what you see, what you don't see is just as important. Beta testing in factories, screening out units that fail reliability tests, performing environmental stress screenings, heat, cold, humidity, drop impact. These steps ensure that when you buy it, it works in your environment, whether you're using it in a humid city, a desert, or a snow-covered town. The factory and QA answer to that real-world expectation. And let's talk about volume and risk. Producing tens of millions of units within weeks of launch requires factories to ramp rapidly, train staff, calibrate machines, source parts. If one supplier fails, alternate routing or backup production must exist. That's why manufacturing planning begins years before the final reveal. The assembly lines are laid out months ahead, robotic cells qualified, operators trained, parts warehoused. When the one more thing launches on stage, that phone arriving in stores is the visible end of a near-invisible global machine. Factor in costs, component shortages, currency swings, labor dynamics, transportation bottlenecks all pressurize margins. Factories can sneeze and the ripple reaches your wallet. That's why modern manufacturing strategies include inventory buffers, multi-sourcing, regional diversification. We're seeing that shift now with smartphone manufacturers who cannot rely on one country or one line to deliver the world's supply. Let's zoom back out and see how the factory concept itself has changed. It's no longer one giant factory in one place. It's a network. Some modules are made in Korea, shipped to India, others in China, shipped to Europe. Final assembly might happen in one country, refurbishment in another, packaging in a third, and logistic hubs connect them all. For this latest flagship, the network has grown even more geographically distributed, multi-sourced, automated, and responsive. That's the only way to meet global demand. Tight launch windows and premium margins. From the end user perspective, what does this mean? It means the device you hold has passed through more hands, machines, audits, and test cycles than most electronics in your home. It means that every aspect, from the feel of the side button to the warmth of the finish to how the camera captures color, was likely fine-tuned at a factory floor somewhere or in front of a CAD console months ago. It means that the final product is as much a testament to manufacturing discipline as it is to design genius. Before you send your new phone on its first charge, imagine the journey. The sand carved out of the earth, the quartz refined, the chip etched, the screens polished, the cameras aligned, the antennas tuned, the board assembled, the chassis pressed, the factory humming, the quality gates spanning continents, the packaging filled, the supply chain humming, and then a plane crosses the sky delivering it to you. That story gives new meaning to designed in and assembled in. It reminds you that in a world of global tech, your device is the endpoint of thousands of kilometers of parts, people, machines, and decisions. But the real marvel isn't just the machines or materials, it's the coordination. In Apple's factories, every movement is measured down to milliseconds. Cameras monitor workers' actions to ensure perfect synchronization with robotic systems. Algorithms optimize conveyor speeds and even control ambient temperature so adhesives cure at precise rates. Every screw, every connector, every cable follows an invisible script written by years of refinement. Engineers in Cupertino design, test, and simulate assembly virtually before a single prototype hits the production line. By the time it does, the process is already a living, breathing choreography. Then comes automation intelligence, a hidden layer that most people never see. Apple's industrial engineers deploy AI systems that constantly analyze data from the factory floor. Pressure sensors, torque meters, and cameras feed thousands of data points per second into central servers. These systems can detect a 0.1 millimeter misalignment or a deviation in sound frequency when a screw is being driven incorrectly. That means potential defects are caught in real time, not after millions of devices ship. A major secret to Apple's success lies in its precision robotics. Specialized robotic arms equipped with haptic feedback insert components smaller than a grain of rice. Here, robots with sub-millimeter accuracy assemble the triple lens system, each lens positioned within microscopic tolerances to ensure where focus calibration remains consistent across millions of units. These machines operate in clean rooms where the air is filtered 500 times per hour. Workers wear full-body suits, and even a single dust particle could force a production halt. The iPhone 17 marks another leap: modular sustainability. Apple's suppliers have begun adopting recycled materials for structural parts, using reclaimed aluminum and rare earth magnets sourced from retired devices. Even the solder paste now includes recycled tin. Inside the assembly plants, waste heat from soldering machines is reused to maintain temperature stability in testing chambers. The result, the same cutting-edge technology, produced with significantly lower environmental impact, a step toward the company's ambitious carbon-neutral target. To eliminate bubbles, the process happens in a vacuum chamber. The resulting bond must withstand drops, flexing, and years of use. Then comes calibration. Robots align pixels with camera sensors and proximity detectors, ensuring touch sensitivity and Face ID accuracy remain flawless. Thousands of panels undergo burn-in tests before a single one is approved. In another corner of the facility, engineers focus on the battery assembly. It's not just about capacity, it's about energy density and safety. The lithium-ion cells are formed, aged, and rigorously tested under controlled humidity. Apple's safety teams simulate extreme conditions: overcharging, piercing, compression. Only after passing hundreds of safety checks are they installed into the aluminum housing using non-conductive adhesives and heat-resistant films. Every single battery is scanned, logged, and traceable down to the lot number of the materials used. The sound system, too, undergoes its own orchestra of testing. Microphones and speakers are subjected to acoustic scans inside anechoic chambers, perfectly silent rooms that allow engineers to analyze every frequency and distortion pattern. AI-based software then tunes the audio profile individually for each unit so that the sound output remains consistent, even across different manufacturing plants. You might not realize it, but the crisp bass or clean treble you hear is the result of thousands of micro adjustments made during production. Let's not forget human craftsmanship. While the process is heavily automated, there are still key areas where human intuition prevails: visual inspection, finishing, tactile feedback. Workers trained for months learn to detect imperfections that machines can't perceive: the feel of a button click, the evenness of a brushed finish, the subtle glow of a display. Each worker signs off on batches that meet their section's standards, reinforcing the culture of accountability. To them, this isn't just assembly, it's craftsmanship at scale. Another layer of complexity lies in supply synchronization. Imagine thousands of components arriving from hundreds of suppliers across multiple continents, and each part must reach the exact production line at the exact time. If a single shipment is delayed, the entire operation can stall. After final assembly, devices enter the testing gauntlet. Each unit faces drop simulations, vibration checks, and waterproofing trials. Robotic fingers swipe across screens thousands of times to test durability. Cameras capture test images in calibrated lighting conditions. The phone's AI chip runs diagnostic programs, self-checking sensors, GPS, gyroscopes, and connectivity. Only if a device passes every test does it move to packaging. A single failure and it's flagged for rework or recycled immediately. Nothing leaves the factory unverified. Packaging, too, is a science. The iconic unboxing experience is engineered with precision. The soft friction as the lid slides off, the weight distribution, the minimalistic layout. Even the glue used for the box's edges is chosen for exact peel resistance. Workers use robotic arms to align packaging elements perfectly, and sensors check for label orientation and barcode readability. Every sealed box is scanned into the system, linked to its internal components by serial number, traceable all the way back to the raw material batch. Finally, the logistics symphony resumes. Pallets of sealed boxes are wrapped, loaded, and shipped via temperature-controlled freight. Some go by air to launch day markets, others by sea to distribution centers. Each carton carries embedded tracking chips, allowing Apple's global logistics hub to monitor shipments in real time. When you pre-order your phone and see "in transit," you're watching the culmination of this intricate ballet of precision, planning, and technology. If you found this breakdown fascinating, hit that like button, subscribe for more behind-the-scenes tech stories, and ring the bell so you never miss when we deep dive into the next big device. In the comments, tell me, which part of the manufacturing process surprised you most? I'll see you in the next one.